Okay, so this is how we're gonna go over the 6 weeks review quiz. Number one says find the product of these two rational expressions. These two things are fractions, right? So if I multiply, I'm just multiplying straight across from left to right. So for example, if it was 1/2 times 3/4, this would be what? 3/8. We would just multiply from left to right. But if anything cancels out, if there's a factor on top and on the bottom, we can cross them out. So can we factor this one right here? Yes, this is the difference of squares. We can factor that one by doing what? Y minus 2 times y plus 2, right? Difference of squares. Y minus the square root of 4 is 2, right? If this was a 9, it would be 3 and 3. If it was a 25, 5 and 5. Over, how do we factor the bottom? The bottom, this is a 12. What are the two factors of 12, negative 12, that add up to negative 4? This is going to be 6 and 2, right? One of these has to be negative because this is negative. And notice that this is negative 4, so the 6 is negative 4 because negative 6 plus 2 is negative 4. So this is going to be y minus, because there's y's in this case, y is a variable, y minus 6 times y plus 2. Now this is going to be times, we have, you need to be careful right here. You cannot cross these two out because this has a 3 right here. This is going to be y minus 6 at the top over, can I factor out this 3? Yes. If I factor out a 3, I'm going to end up with y minus what? 2. Does everybody see that? So minus 6, 3 times negative 2 is minus 6. Yes? So now we can multiply from left to right, but if anything cancels out, it goes away. So what cancels out? We have y minus 2 on top. Do I have a y minus 2 on the bottom? Yes, right here. Okay. I have a y plus 2 at the top. Do I have another y plus 2 at the bottom? Yep, right here. Do you see that? I have a y plus 6 here. Do I have any at the bottom? Yes, right here. So what's left over? This 3 at the bottom. So the answer for this one is a 3 at the bottom. So what's at the top? Just a 1. So after I multiply, everything cancels out and is 1/3. The next one for 1b, this time we're going to add. So whenever we add, it has to have the same denominator. So for example, if it was 2/5 plus 1/5, this is what? 3/5. I can do that because 5 and 5 are the same. So 2 plus 1 is 3. The denominator stays the same. So these two are not the same. I have to make them the same. I have to find the LCD, lowest common denominator. So before I do that, I have to see if I have to factor them to see what factors they share. So this is, I can rewrite the bottom. Again, I have a difference of squares. So it's going to be what? X plus 5 times x minus 5. Plus 1 over, I can factor out this 2. What's left over after factor out that 2? X plus 5, right? Because 2x and then 2 times 5 is 10. So now I want these two to be equal. So what is missing? So let's look. This one has an x plus 5. This one has an x plus 5. This one has an x minus 5. This one doesn't have an x minus 5. So I'm going to put what? An x minus 5 here at the bottom and the top, because that's what's missing. This one has a 2. Does this one have a 2? No. So I'm going to multiply it on this one. So now they're the same. 2x plus 5, x minus 5. 2x plus 5, x minus 5. Does everybody see that? Just like 5, 5, 5. So now what is going to happen? I can combine them now. But now I'm going to simplify. 2 times 1 is what? 2. Plus, this is going to be 1 times 5, or 1 times x. X, and then 1 times negative 5, which is minus 5. All over, all over, what? One denominator, which is 2 times x plus 5 times x minus 5. And then right here, I just combine like terms. 2 and what? Negative 5 combine to make negative 3. the x stays the same, so it's going to be x minus 3 over 2x plus 5 times x minus 5. And that is all. Nothing else cancels out, nothing else reduces, nothing else combines. That is the final one. Okay? Let's look at the next one, number 2. The cost of baking a cake is $150 per cake plus a one-time payment of $125 for supplies, $125. Which of the following models A of X, the average cost per X cakes? Or that should say for X cakes, but that's fine. So what is the average cost? I want A of X. A is the average. How do I find the average? Where is this going to come from? The average cost is going to come from what? The total cost, right? Divided by what? Divided by the total cakes. Yes? I want to know the cost for each cake. So the total cost divided by the number of cakes. So the average cost, it said it was A of X, right? A of X is going to equal to, where's my cost going to come from? My cost is going to come from $150 per cake. So what is that going to look like? 150 times X, right? X is the cakes. If each cake is 150, then it's going to cost me 150x per cake for X cakes. Now, is that all that I spent? No, I also spent 125, so I'm going to also add 125. Is that the total cost? Yeah, this is all that I spent. Now, I have to divide it by the total amount of cakes. So how many cakes did I bake? I don't know, so X is the cake. That is the average cost. That is the equation. Let's look at number 3. Number 3 says find the solutions for this equation. This is a equation, rational equation. Hint, find the roots. So that's going to come in later. Let's look at this. I want to find the value of X that makes this true. So first, right here says to subtract. If I want to subtract, what has to happen first? I have to have an LCD. This has an X. This has X plus 2. This has what? 1. It has nothing, so it has a 1 at the bottom. So this has an X. What is missing on this one? An X plus 2. Well, the 1, you don't have to put it. The X plus 2 is missing, so I'm going to put an X plus 2 here and at the top. Right? What about this one? What is this one missing? This was missing the X. So this is going to be an X, so an X at the bottom and an X at the top. And we're going to multiply it, right? And then this one has a 1, so this one has neither one of them. So we're going to put both. X times X plus 2, right? At the bottom. And X times X plus 2 at the top. So we haven't done one quite like this one. So now this is an equation, which means once all the denominators are equal, so right here this is a parentheses. Once all the denominators are equal, they can do what? They can go away. So all I need is the top now. So what happens at the top? 3 times X, 3 times 2, 3X plus 6 minus, right, this is the minus, 6 times X is equal to 1 times X, what is this? X squared plus 2X. Yes? So now look, this is if I want to solve for X, this has a quadratic. So how do I find the solutions for a quadratic? I have to find, first of all, I have to set it equal to 0 and find the roots. So that's where it came from when it said find the roots. That was a hint. We're going to have to set it equal to 0. So that means we're going to have to bring everything to one side. Since this has the X squared, let's bring everything to the right. Okay? So we have 3X minus 6X. We can simplify this to 6 minus 3X, right, is equal to X squared plus 2X. Now if I bring it over, right, if this 6 comes over, now it's going to be a minus 6. This 3X, if I bring it over, is going to add, right? 3 plus 2 is going to be 5X plus X squared. And now since nothing is on the right, it is equal to 0. So how do we find the solutions? How do we find the roots once it equals to zeros? We factor it. So what are the factors of 6? Negative 6 that add up to 5. It's not going to be 2 and 3. It's actually 6 and 1. Okay. One of these is going to be negative. Which one's negative? The 1 is negative because 6 minus 1 is positive 5. 6 times negative 1 is negative 6. So 0 is equal to x plus 6 times x minus 1. And then, so what are the solutions that come from here? X plus 6 equals to 0 when x is equal to negative 6. And x minus 1 is equal to 0 when x is equal to 1. So those are my two solutions right there. Does everybody see that? Another way you can actually find the roots is to actually graph this right here. You can graph this into the y equals in your calculator, and it's going to show you that it's going to have the roots at what? At negative 6. If you count them, it's going to be at negative 6 and at positive 1. You can use that just to double check, right? Okay, let's go on to number 4. Number 4 says a circuit with a 5 ohm resistor gives the following equivalent resistance when a second resistor with X ohms of resistance is attached in parallel. It follows the model. R is equal to that. If the equivalent resistance R is 3.1 ohms, can the second resistor be 8.2 ohms? Yes or no? So this is just how a resistor is behaving. Okay. This is a circuit. So R is the equivalent resistance, so the final resistance of both resistors put together, and X is the second resistor. So how do we check if this is true or not? Well, we'll just do what? Plug it in, right? R is 3.1, so I'm going to stick a 3.1 in there. And X is 8.2, so I'm going to stick a 8.2 right here and right here. Right? And I'm going to see if it's true. So let's do it. So this is R is 3.1. 3.1 is equal to 5 times 8.2 over 5 plus 8.2. I want to know if this is true. So how can we check? We just go to the calculator. And so let's do that. So I'm going to do this right side. If it's equals to 3.1, then we're done. So 5 times 8.2 is equal to that. And then divided by, I'm going to put this in parentheses, 5 plus 8.2. Okay? So let me just put it all in one so you can see it. 5 times 8.2 divided by the whole bottom, 5 plus 8.2 is, what is it supposed to equal to? 3.1. Is that equal to 3.1? Yes. So is that the one that fits? Yes. The answer is yes. We checked it. Let's look at the next one. Number 5. The graph of negative 1 over x lies in what quadrants? Well, what is the parent function of this one? The parent function of this one is just y is equal to 1 over x, right? Where does that one lie in? That one has the asymptote right here. Has the asymptotes at 0 on y and a horizontal asymptote at 0 on the y-axis, on the x-axis. Yes. And normally it is right here, right? But which it doesn't want? It wants to know when it's negative. Where's it going to be if it's negative? So just to recap, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay? So if it's negative, it is going to do what? It's actually going to flip, and it's going to be in this quadrant and in that quadrant. So it's actually in quadrant 2 and 4. 2 and 4. That is